I'm glad we are having this discussion with you folks. There's really a lot of new stuff that's come off the truck in the recent past, and it'll be really great sharing that with all of you. We've got a bunch of good product demos lined up today, so you'll have the chance to deep dive into the product. And to kick us off, what I wanted to do was just give the big picture, right? What's our strategy, and really how we're looking to transform the firewall market in particular. And so if we just step back for a second, fundamentally what we're trying to do is building an entirely new kind of data center firewall. One that's based on scale-out elastic software instead of the bespoke hardware that we're all used to. Security that's built into the fabric of the infrastructure, really making it pervasive and is highly automated, API-driven across all the security services, essentially bringing what we like to call the public cloud experience to on-premise infrastructure. And so, just to sort of kick us off with the metaphor, right? Security that's bolted on really just never works really well, right? You end up sticking multiple products on top of each other. It's complex, it doesn't look good, and fundamentally just never works as well. And sort of you compare that to when you build security into the fabric of the infrastructure. It's pervasive, it has all the context. Fundamentally, when you build it in, you build that security differently, and it just works better, right? And that's really the philosophy with which we're approaching the security market and disrupting it at VMware. If we take that canonical credit agency breach that we're all familiar with, the attacker came in through a unpatched Apache Struts server. And that's not the surprising part, right? It's not surprising that they found some vulnerability somewhere across your environment, across the customer environment, or the fact that the perimeter firewall in some way was missing some policies. That's not surprising. What really was worrisome is that the attacker was able to make 48 lateral moves over time, over a period of 9 months, to finally reach the sensitive data and harvest those hundreds of millions of credit card numbers and exfiltrate those, right? And so this is really sort of underpins that fundamental assumption with which we are approaching security, and network security in particular, is that assumption that the perimeter invariably will be breached. And the challenge in front of us is to make it incredibly hard for the attacker to stay or move inside the network, right? And that's the problem that we're laser focused on as VMware. And so, and really, that's an unimaginable cost, right? Just in one day, they had a drop of $3.5 billion in market cap after that announcement. And so it's almost like, if somebody breaks into your house, steals your laptop or steals your sensitive papers, you'll be really pissed, right? You'll be annoyed as hell. But if somebody is sitting inside your house, going room to room, sitting with your family at the dinner table, listening to every conversation that you're having for 9 months on end, that's unimaginable, right? But that's really the state of our data center security today, right? And so fundamentally, our belief is, securing your east-west, your data center, it starts with protecting every server, every workload. And that's where, with the acquisition of Carbon Black, we're putting that next-gen AV, EDR, the endpoint protection into the hypervisor so that it's there whenever a new workload is spun up. It just spins up with the right kind of endpoint protection, right? And any new workload that spins up, it always has vulnerability scanning built in, right? And so if you're running any vulnerable software. The next step from there, and this is a space we pioneered as VMware, over 6 years ago, microsegmentation. You start cutting up that network into more sensible pieces, right? Instead of having a completely flat network. And that historically has had its share of challenges. And we, over the last couple of years, have built this exciting capability, which we call NSX Intelligence, that really helps operationalize microsegmentation. And Ray on our team will walk through a detailed demo about NSX Intelligence, but how it does application discovery, policy recommendations, policy enforcement, compliance checking for the policies. That whole life cycle of policy management has been highly automated and brought together in a seamless workflow out here. But then, microsegmentation solves a fundamental problem, but it's a basic problem, right? That your web should not be able to talk to the DB. right? That's just, it's just the wrong traffic flow, and that's definitely a problem you should solve. Um, but what we've realized over time is that the attack vectors and the nature of the attacks is going way beyond that, right? The attackers are traversing allowed pathways of communication, and so if you take a WannaCry or something, you can't the attackers and the malware spreads over the SMB port across your file servers. You can't turn off the SMB port. That's a legitimate port that you have to keep open. And so you really want deeper packet inspection on the traffic that's flowing over the network, right? Layer 7 inspection with App ID, with intrusion detection, and that's where we're bringing both signature and anomaly-based detection on the east-west traffic flows, so that every single packet at every single hop is being inspected to see if this is malicious traffic or is this good normal traffic that we expect and want should be traversing between the applications. And Stein on our team will walk us through sort of the new innovations that we've brought out with the NSX distributed IDS IPS in this context, right? And so where are we going with this, right? If you see now, we have two fundamental capabilities, and really uniquely as VMware, we're probably one of the very few companies that has market-leading positions in both EDR with Carbon Black and with network anomaly detection, network security with the NSX and the service-defined firewall, right? And if you put that together, you get what Gartner's calling XDR. And sort of just to bring it to life, right? If I'm sitting on a server and I see this anomalous process, it's an Apache server, I see a process ABC123XYZ.exe, and in the cloud, our Carbon Black Cloud is able to see, you know what, across my fleet of hundreds of thousands and millions of Apache servers, I've never really seen this process. That looks a bit fishy. But then, okay, let this go on. And then I see it make a DNS query over the network from my network security out to, some Eastern European server, and that's flashing some alarm bells. And then it makes a massive query to the database and requests a couple of 100,000 credit cards. Then I know I've seen enough, right? And I know I need to block it. But that's the power of tying together visibility into every process and what are the network calls and communication that process is making. Tying that together allows you to really accurately detect those indicators of compromise and be able to take action extremely fast. And so how are we going about doing this, right? And we like to call this the end of the black box era, because fundamentally, if you think about what have we been doing for the last few decades, is just taking a box, sticking in more and more features into it, or taking that box, making it a blade, and sticking it into a switch or a router. But it's the same firewall repackaged in different form factors. And invariably, what we're doing is when workload A is talking to workload B, it's hairpinning the traffic through some other appliance. And that's expensive, right? Whether it's the firewall, whether it's IDS IPS, whether it's load balancing, analytics. In each of these cases, you're hairpinning the traffic that creates network bottlenecks, that creates architectural complexities, and fundamentally creates throughput limitations, right? And so what we've really done is taken that firewall and essentially like broken it into 1,000 little pieces out at every single workload, right? And stuck it at that workload to do all the traffic inspection locally. And then we did the same thing with the IDS IPS. And then we've done the same thing with the load balancer, right? And the same thing with all the traffic analytics. So instead of having these expensive bespoke appliances that are taking racks of space, energy, and your CapEx, literally move all that processing out to the workloads, right at the source of the data. So you have the context, it's pervasive, it's there. You don't have to make any, you don't have to do selective traffic inspection, right? You have absolute coverage with no blind spots. The other thing that it gives you tremendous insight and awareness of what is the application and the service that's running. And so if you take a simple example of IDS IPS, right, because we know what is the application running at every single workload, typical IDS IPS will have like 10,000, to the order of 15, 20,000 often signatures. But because we know what application is running, we can actually curate the signatures, and only the relevant signatures need to be evaluated at a given workload. If it's an Apache server, there's really no point running MySQL signatures out there, right? And this radically reduces the computational overhead and the number of signatures that you need to run at every workload, reducing the false positives as well in the process. We do the same thing with the firewalls. We can do the same thing with the WAF so that you just run the relevant rules at the right places. And that's the power of being inside the infrastructure and having all of that deep application visibility and service context, right? The other power of that is the automation that we are able to bring to bear. Because we understand the applications and the object-based policy model that we have, when a new workload spins up, it just inherits the policies of the group that it's part of. So if a VM that comes up is part of the web tier, any new VM that comes up into the web tier automatically inherits the policies for that group, right? You don't have to go ahead and deploy the policies manually right after you deploy the workload. It automatically inherits those policies. The policies move with the workloads as they go with, as the workloads move, right? Without dropping any connections. And all of this inspection, because it's done in the hypervisor, you're able to do it in a single pass, right? So as the packet is traversing out to the NIC, you can do the firewalling, access controls. You can do the IDS IPS, the traffic analytics, and so on, which makes it highly computationally efficient and optimized. And the policies, when the workload dies, the policies go with it. So it's no more of that stale policy problem anymore that plagues us in the firewall world. And all of this works not just for virtual workloads, containers, VMs, bare metal. We treat them all as first-class citizens operating across clouds, right? And so today, with that sort of background, the two products really that, just to give you a marker of what's coming next, the couple of products that we'll focus on in the next couple of next few sessions is, one is our internal east-west firewall, which we call the NSX Service-defined Firewall, right? We'll start, and Stein will walk us through a demo of the core distributed firewall and its, some of its main use cases. Then we'll jump into the distributed IDS IPS, which is the new product we announced back at VMworld Barcelona. And then Ray will walk us through NSX Intelligence, sort of the whole distributed analytics policy management engine that I talked about. And then we'll jump into the other data center and cloud firewall we have, which is the web application firewall, part of the NSX Advanced Load Balancer that we acquired with the Avi Networks acquisition last year. And Ashish will walk us through that. So that was a quick introduction to the overall network security strategy with us here at VMware. With that, I will pass the ball over to Stein, who'll kick us off with a demo on the distributed firewall for data centers and clouds. Stein, I'm going to stop sharing. Over to you.
Okay, excellent. So hopefully you can all see my screen here. And I would like to cover, as Drew mentioned, the VMware Service-defined Firewall. And this is going to be a brief demo. And I was thinking, as we are all, a lot of us are working from home, I wanted to focus on the use cases that are very relevant to that. And we at VMware, we've seen a huge uptake in customers that are using VDI infrastructure, a huge increase in scale of VDI deployments, in order to enable employees to have access to their same applications that they're used to having access to from the office, now also from home. And from a security perspective, NSX has a couple of really major use cases with VDI. Number one, and I'll briefly mention that one, not going to actually show that one in the demo today, but it's protecting the actual VDI infrastructure. Whether it's Horizon or Citrix, these are rather complex infrastructures. And we have the ability with NSX to microsegment these infrastructures in order to reduce the attack surface, in order to protect those management components. Another big use case, and this is very simple, and this is isolating VDI desktops or VDI desktop pools. This is where with a single distributed firewall rule, you can ensure that there's no lateral movement between desktops. You can basically isolate every single desktop from every other desktop, regardless if these desktops are sitting in the same VLAN or they're sitting somewhere in a different VLAN across the network. And then the last one is what we call secure user application access. And this is where with our distributed firewall, we have the ability to distinct traffic from different users. Our solution doesn't require an agent for that, but we're basically able to fingerprint every user who's generating a particular flow. We tag that flow with the identity of the user, and that allows us to provide the HR users, for example, access to the HR application, but not to the finance application. It's a very powerful use case, and this applies to both VDI scenarios where there's a one-to-one mapping between user and desktop, but also RDSH scenarios in which multiple users connect to a single server, a jump box, or a server to access their published applications. In both of these scenarios, we're able to distinct and apply differentiated user policies. So that's kind of just setting the stage of why I chose to kind of use a VDI scenario to cover our demo today. And this is the demo topology. And in the session after this one, in which we'll cover the distributed IDS, I'll use a very similar, in fact, the same topology. So I'll go through a couple of things that we'll be doing in the demo. First of all is actually microsegmenting the infrastructure and isolating the environments. And this is often where customers start when they start on their microsegmentation journey. This is very easy. This is basically your high-level segmentation. And in this case, this is a VDI infrastructure. So there's a pretty complex setup that we have here. We're using our AVI Advanced Load Balancer, which sits in front of a couple of unified access gateways or UAGs that provide connectivity into the VDI infrastructure. We then have some Horizon connection servers, which basically provide desktop availability, load balancing between available desktops within a particular pool. So what we're doing here is we're applying a microsegmentation policy so that only the required flows for this infrastructure to work are allowed. And at the very end of our firewall rule, we have to deny any rule. Then in almost all customers' environment, there's a shared service segment as well, where we have common services like Active Directory, NTP, DNS, DHCP running. Also with NSX, we provide a policy to limit access to these shared services. And then we have what we call environment and isolation. And this is where customers have a production environment and a development environment. Typically, those environments do not need to talk to each other. So we have the ability to isolate these from each other. And we can do this very dynamically. All of our customers who have been very successful with microsegmentation leverage something called dynamic security groups. And this is where you group a number of workloads together that need a common policy. And that grouping can be based on things like VM name, if you have a solid naming convention, which is not always the case. Or it could be based on a security tag, which is applied to a workload. It can be applied at the moment that the workload is being deployed. It can even be defined in a blueprint, or it can be deployed. It can be applied to a workload at any point in time. Maybe if the security posture of the workload changes, you can apply a different security tag. As a result, the workload becomes a member of a different security group, and then a different policy is applied. But in this case, we are applying a production tag to our production workloads, and that's effectively isolating these workloads from the development workloads. So that's our high-level environment isolation and microsegmentation of the infrastructure. So this is where I'll start my demo as well, and this is the actual microsegmentation of applications. And this is, of course, the number one reason why our customers deploy NSX. And you can see that in my environment, I have a couple of applications here, two three-tier applications of an MRS, a medical application, and then an HR management application. So what I'll do is I'll create a microsegmentation policy that effectively is a whitelisting policy. We're only allowing the flows that the application needs in order to function. And I'm not going to do this manually. Instead, I'm going to use what we call the declarative API, which allows us to define our intent. We basically define what is required, what do we want the outcome to be in a single JSON file, and then using a single API call, we can realize that configuration. So that's going to be where I'll start the demo. And then the next thing that I want to show is isolating the desktop. So this is where I mentioned that with a single distributed firewall rule, we can ensure that all of these desktops are completely isolated from each other. Because typically in a regular VDI desktop pool, these would be deployed in a single VLAN or a single subnet. They would be able to communicate with each other. So that's why this is one of the key value props of NSX when it comes to VDI, is that with a single distributed firewall rule, you can ensure that these are isolated so that threats, ransomware, for example, cannot spread from desktop to desktop in your environment. And then the last thing that I'll do as part of this demo is a user identity-based policies. And this is where we have two users here on the left that are logging in from their home. They're connecting to their VDI desktop. And then from there, we can provide them differentiated access policies. We'll see a medical user here who's only able to access the OpenMRS application, while the HR user is able to access the HR application and not vice versa. So with that, let's start with the demo. So we'll start with microsegmentation here, and this is our distributed firewall. And here we go into our API. And I mentioned I'm going to show you the declarative API, which allows us with a single API call and a single JSON statement to define what is our desired outcome. And if we look at the configuration on the screen here, you can see that you're looking at what we call a group or a security group. And a security group is a way of grouping workloads, grouping VMs. And the way that we've grouped workloads in this example is based on a security tag. That means that any workload here who has a security tag applied to it that has a value of HRM web, that workload will become a member of this security group. And this really is what enables our dynamic policies. And Ruth mentioned earlier, if an application is decommissioned, we can clean up the policy right away without any user interaction. You do not need to modify a firewall rule. You do not need to remove the firewall rule. The realization, the data plane instantiation of the firewall rule is automatically adjusted when that workload is removed or the tag is removed of that workload. That's a very powerful concept. So here you see the HRM security group that is matching any workload that has that HRM web tag applied to it. And then we do the same for the HRM app, the application tier of the HRM application. And then we specify a service. And in NSX, we support both layer 4 as well as layer 7 services and also ALGs, application level gateways. In this case, this is HTTP as a layer 4 service, so port-based. And then on the next line, you see profiles. That's an actual layer 7 enforcement. So here we are ensuring that the traffic that we are allowing is actually HTTP traffic traveling over port 80. So any other protocol that tries to tunnel across that port, perhaps exfiltration or perhaps a client-side tag going to an outside server, is going to be denied unless it's HTTP traffic. So now all we have to do is actually enforce this policy. By the way, you can also see the scope here. The scope is what we call apply to, and this defines the span of this particular rule. Obviously, if you have a large data center environment, a database tier or a database of this application is never going to see traffic between the web tier and the application tier of that workload. So this is why this is where using the scope is really useful to limit which VMs do we actually apply this firewall rule to. And that's what we're defining here in the scope. So once we've done that, the very next thing is actually sending this call to the NSX manager. And now we can switch over to the UI. You can see that this was successful. So now in the UI, I can refresh my screen. And you can see here that our two applications, my ICE HRM and my OpenMRS application, have been added. And we have our microsegmentation or granular microsegmentation policy between the two here.
I just have a quick question.
Absolutely.
Mind you, apologies if you've already gone over this, but a bit of the audio on my end was kind of a bit robot-y, so I might have missed it. But essentially, from what you demoed, we have to create asset groups or whatever specific types of groups, which then we apply the policy to. Is that what you were going through in that?
Yes, yes, okay. Exactly. So the groups that you're creating are then used in your firewall roles, in your source and destination. That's what we call groups or security.
Okay, source and destination specific. Okay.
Exactly. Yeah. Mm-hmm.
And these, do you have to manually create each of these, or can you? Because I know in some software when you have groups, you can do dynamic. I'm thinking more asset groups, mind you, so it could be a bit of a challenge here. But you can create a way that it automatically picks it up, or do you have to go through and manually create each one?
No, I think I got the question, and definitely you do create the group manually, but then the membership can be dynamic. So you can define a group, for example, and you can say any VM that matches this name, any VM that starts with the name web, for example, is dynamically going to become a member of this group. So that means then you spin up a new workload the next day, the VM name matches. As a result, that workload dynamically becomes a member of that group. Or through security tags, which is very common. Almost all of our customers use these security tags to identify, for example, that a workload is deployed in production, or to identify that this workload is part of that particular application, or it's the database tier of an application. Most of our customers apply between 3 and 5 security tags to a workload. And as a result of a security tag being applied, again, the workload then becomes a dynamic member of a security group. And as soon as the tag is removed, the workload is also removed from that group. So that's what enables a dynamic policy. That's what enables a policy that gets reflected automatically without you as a user having to go in and adjust the firewall rule manually when an application has been decommissioned, or when you're onboarding a new application. You can use these existing grouping constructs.
Okay, that makes more sense. Sorry, a bit of that was cut out, so I wasn't quite sure what you were saying.
Yeah. Sorry for that.
And just to add to that, Ray will talk about how we actually even automate this discovery and policy creation process in the first place with NS6 intelligence.
Stein, I have an additional question. It's kind of cool to do tag-based firewall policies, yeah, that removes a lot of the, let's say, fiddling around with IP addresses and so on, yeah, makes our life a little bit easier. How is it with exchanging these tags and groups? So I'm coming from, for example, I have a company, they are acquiring another company, they have their own NSX environment and their own farm. Can I easily, let's say, have my tags integrated to another environment and exchange that? And is this also possible for the web application firewall world?
So, these tags are not something that is carried on the network. So tags are locally significant. But you can definitely create the same security groups. You can absolutely create a same security group that is going to match the same workloads and create the same tags in both environments. It's purely a management plane construct. So you're not going to attack in.
Sure, but if I have this nicely organized in my environment and I need to do this for another environment, of course, always there's some manual task and maybe copy paste involved. Yeah, so it would be great to have this somehow automated. Yeah,
we do have federations.
Right here, I thought I might jump in and actually mention that one of the new features we did release is Federation, which gives us a global policy management layer that allows us to actually have consistent policy across different NSX domains. So we could essentially import, policy from one environment up into our global layer and then use it across different environments as well. So that is also part of our firewall and security management plane strategy.
Okay, great. That would be the perfect match for the acquisition or merger case, yeah?
Exactly, yes.
Okay.
Also a question from my side on the having multiple tags. What are you doing with conflicts of interest? If you have one tag with a source and destination that says permit, and the other tag assigned dynamically says deny, how are you going to handle that?
So the tag itself, there's no policy applied to the tag itself, right? So let's say you have a workload and there's 2 tags applied to that workload. One tag that says this is production, another tag that says this is the database tier. And as a result of that, there's multiple firewall rules that apply. The answer is that this is really no different from any other firewall, in the sense that by virtue of tags being applied, the workload becomes a member of one or more security groups. And then we evaluate the traffic in the firewall itself, top to bottom. We go through the first rule at the very top of your firewall rule table. If that's a hit, then we exit the firewall rule checking right there. So that's really that is no different from a traditional firewall.
There's a chance when the firewall policies are merged that it's a chance of risk, whether it's a permit or a deny.
Is there? Sorry, Just on top of that question you just asked, actually, is there a view that you could see that conflict? Because you know how on like a website, for example, and you do inspect element, you can see all of them that apply to that element, so you can kind of cross out, oh, that's what's fucking.
Yes. Yeah, so there is a VM-centric view that allows you on a per VM basis to see what the effective policy is that has been applied to that VM.
But as Peter mentioned, there's nothing that you can do priority-wise, or there's nothing that, like, would one get priority over the other, is what I believe you were asking.
Yes. Yeah, whatever is higher in the firewall rule table is going to take priority.
Stein, a question on that then. Is there a view where you can see where is it smart enough to understand that there might be conflicting firewall rules from multiple groups? Because tags is very powerful and these grouping mechanisms are very, very useful. They also tend to get very complicated quite quickly and lead to really obscure and fun and exciting bugs. Particularly with security stuff, that can sometimes mean that you're allowing traffic that you didn't mean to allow, or sometimes worse, you actually deny traffic by accident that should work, and then you drop connections to your production database, which tends to make people sad. Right. Is there a view to help you with diagnosing those things? So you could, for example, highlight this VM is a member of two different groups. These firewall rules overlap. I'm only applying the first one, but there's ones further down here. You might want to check that these don't conflict in weird and wonderful ways that the stupid computer doesn't fully understand.
Right, yeah, so there is a VM-centric view. We do not in NSX Manager show like if a role is being shadowed. That's not something that we display right now. I think what Ray will be showing in NSX Intelligence, I think that's going to address at least part of your question. So I think maybe that's something that will be of interest as well.
Great, I look forward to it.
Okay. So here is kind of what I mentioned, the apply to concept. And this kind of shows, I just clicked on the success there, meaning that these firewall rules have been realized on the hypervisor. They have been implemented and sent down to the actual hypervisor for enforcement. But of course, we don't have to program our firewall rules everywhere. So this shows that for this particular section here, the OpenMRS section, we've applied the rule to these two hypervisors. And that's because our VMs that make up the MRS application only reside on these particular hypervisors. So, we can be very granular of where the rules are applied. Also, the rules actually move right along with the virtual machine. When a VM motions, the rule set, as well as the actual connection state, moves right along with the VM itself. And then, as you can see that these rules are actually using a layer 7 application identity, and that's what we configured there in profiles. So here we've allowed TLS version 1.2. We can change that. For example, let's say, well, we really need to allow TLS 1.1 and above. We can create a new profile, add the attributes or add SSL, and then select the specific TLS version. In this case, we want to allow 1.1 up to 1.2. So we do have the ability to add a cipher suite as well. If there's certain cipher suites that you only want to allow certain cipher suites, you have the ability to do that as well.
Okay, so I mentioned earlier when I showed the diagram that there's a bunch of desktops that we make available to our employees, and we want to make sure that we're isolating the desktops from each other, basically. And we can achieve that using a single distributed firewall rule, which I've added here. And we put our desktop group as both the source and the destination of that role. And you can see when you, in order for a desktop to become a member of the group, we basically match the name of the desktop here. So any VM, if your organization needs to scale up, you need to deploy additional desktops. As long as you match this naming criterion, these desktops become a member of these security groups and will be by default isolated from the other desktops in this environment. So we can confirm that as well. I log in as a user to one of my desktops, and I try to ping another desktop, and you can see that that's, of course, being rejected. Now, just to prove that this is actually working, I can turn off this rule and publish that, send the configuration down to my hypervisors. And now, as soon as I go back to my desktop and I try to ping, you can see that this time the ping is being allowed. So this shows that with a single distributed firewall rule, we're able to isolate every desktop from every other desktop in the environment. And then finally, we get to user identity-based policies, which is the ability to apply specific user application access. And we do that again without requiring an agent. And in this case, I have my two applications here. There's my HRM and my MRS application. So an HR and then a medical record application. And I'll have two users. I have a doctor as well as an HR user. And you can see now that these were the same policies that I was showing earlier for the HRM app and then the MRS app, but I've added two roles into each of these policies. And the first role here for the HRM application, this allows the HR staff to access the web application. The rule below that is basically denies any other user that is connected into my VDI desktop from accessing this particular HRM web front end. The rest of the rules for this particular application are the same as before. I didn't change those. And then for the MRS application, I did the same, but with the medical staff users. And now let's have a look at this actual HR staff object that you can see here, this HR staff security group. Because these security groups, when it comes to user identity firewall, these security groups are based on an Active Directory group. So NSX can talk to Active Directory, it can retrieve the list of Active Directory groups, and then you can create a new group in NSX, which maps directly to an existing Active Directory group. As you can see here, that this HR group or HR NSX group is matching to the HR group in our Active Directory. And this is what allows us to differentiate users and apply a different set of firewall rules to different users.
Just a quick one regarding this. How
Sure.
do you actually grab the user? So you are looking at the live traffic and looking at the authentication request, or where do you get the user context?
We get it from VMware Tools. So for VMware Tools has built-in drivers that allow us to intercept the TCP sockets, the TCP connections, and VMware Tools also has information about what is the actual user that is logged in and is generating a particular flow. So that's how we're able to do it. We don't require log scraping. We don't require any additional agent to be deployed to do that. What we effectively do then is once we've identified the SID of the group that the user belongs to, we then almost tag that flow with the SID. So when that flow then reaches the distributed firewall, the actual distributed firewall at the VNIC, we then map the tag of that flow with the SID that is also programmed in the role. So there's no mapping based on IP address. It is mapping in the data plane based on the actual SID of the Active Directory group.
And you have that only available for Microsoft Windows-based systems, or do you have any kind of integration for Linux-based user authentication?
So this is Windows.
Okay. Any plans for Linux in the future, maybe?
We're looking into that. We're also looking at what support for physical systems, which will be based on log scraping. So if you're not logging in from a VDI desktop or not from an RDSH system, but you're accessing your applications from your own physical laptop, then this is a feature that we will be adding that we're looking at adding as well.
Okay, great.
Great. So here I can create a new group, and you can see I've retrieved all of the Active Directory groups from my Active Directory server. Contractors, for example, this would be a new security group, and I'm just going to cancel out of this. So now let me confirm that our policy that is based on this Active Directory group is actually working. So I'm logging in as Ed here, who's an employee, and he's a doctor in our medical staff. So he's going to try to access the MRS application, and hopefully that's going to work, because the policy entitles him to do that. And as you can see, he is able to access that. Now, when Ed tries to access the HRM application, that's going to be denied. And again, it really doesn't matter if this, multiple users that belong to different groups are accessing these applications from their individual desktops or from the same RDSH host. We are able to distinct that traffic. So now Aileen is logging in, and she's part of the HR group. And she's going to try to access the medical record application, which she's not entitled to. That's being refused, but she is able to access her HRM application. So this is exactly working as intended. And now the one last thing I want to do here, and this is really setting up for the next demo, is creating a quarantine policy. And this is where we add a single firewall rule. And this rule, we do that in our emergency section here. Quarantine policy, and you can see that I've already added a rule here, and this rule is applied to any a security group that I called compromised, and the definition of that security group is any VM that has a particular tag. this tag here is set to Trojan activity. So any VM that has been tagged with that will become part of this group and will, by virtue of this quarantine rule, we will drop all traffic coming in or coming out of that workload. The reason I'm adding this is because I'll be using this as part of the IDS IPS demo, which will be next. And with that, Dhruv, I think back over to you.
Just a quick question. When you said
yes.
where it has that tag, the Trojan tag, I might have missed it, but how does it getting that tag? Is that just the system is recognizing its unusual activity and tagging it?
Well, we're doing it through the API. So, a tag can be applied by anyone who can use our API. It can be us. We can do it. A user can do it manually. Any third party can integrate with us and can choose to apply a tag to a workload. So in my case, I'm just using a script, which is basically looking for particular indications of compromise, particular IPS signatures to fire. You'll see that in the next demo. And then based on that, if these particular signatures that are of interest, if these fire, then we trigger a bunch of actions. One of these actions is applying a tag to a workload in order to quarantine the workload. And there's a bunch of other actions that I'll take as well.
Okay, and then my other question is, and maybe this is covered in the next one, so if it is, just push it off. But when it comes to getting this kind of almost like intelligence feed, is this something that I can shut up? Like on some sides, I see the positive. It could pick it up automatically, and maybe I don't recognize it, but you guys have something in the back that you've got set up to do it. But also in a very sensitive system, for example, that maybe I don't want to subscribe to that. Is there like can I have it pick it up without actually blocking it?
Oh, so like an intrusion?
Yeah, like not just detection versus the prevention.
Oh yes, absolutely. Yeah, absolutely.
I couldn't see in that setting. Sorry.
No. We didn't get to IPS yet, right? But yeah, in IPS or IDS IPS, in the current release, we support intrusion detection. We can automate additional actions by leveraging the API, like quarantining, those kind of things. But if you just want to detect and be alerted whenever an intrusion happens, then that's, absolutely. That's exactly what we do in the 3.0 release. Okay,
sorry. It's a bit small, so I wasn't quite sure if I was seeing it all.
Oh. I'm sorry for that. No, we didn't really get to the IPS or IDS piece yet, though. So, yeah, what we covered was firewall roles. You can definitely configure a role, allow or deny roles, and you can enable logging if you just want to see what traffic is actually being matched by an allow role. You definitely have the option to do that.